Hello viewers, this is Dr. Sumit Bakshi. Welcome to SPSS tutorial. In this tutorial, I will demonstrate how to conduct paired sample t-test. Paired sample design is also known as within subject design or repeated measure design. When we compare two related means, we use paired sample t-test. Here I am assuming same research problem which I have taken in one sample t-test. Research problem is to study the effect of cooperative learning on marks of students. I want to know whether cooperative learning increase, decrease or there will be no significant change in marks of students. I am taking same example to give you the better idea about when to use one sample t-test or paired sample t-test. In one sample t-test, sample mean was compared to already known population mean. There was only one group and data collected at once only. But here we will have one group and we will collect data on two occasions from that group. It means from pre-test and post-test. Basically, paired sample t-test is used when we have data from same respondent on two different occasions or on two different questions. For example, I can compare marks of same students on two different subjects. So in that case, it will be paired sample t-test. Now the null hypothesis will be there is no significant change in marks of students when taught through cooperative learning. Here we will conduct a pre-test before intervention and post-test after intervention. So I will have two tests, pre-test and post-test. The same sample of students. We will analyze whether there is significant difference in marks of students in pre-test and post-test. So my null hypothesis will be marks of students on pre-test is same, there is no difference with the mean marks of students in post-test. Now to perform paired sample t-test, I have taken the same fictitious data of 25 participants which I have used in one sample t-test. Difference is now I have separate scores marks of students for pre-test and post-test. To conduct paired sample t-test, click Analyze, then Compare Means and then Paired Sample t-test. Now I have two variables which I wish to compare. Move any one variable to variable 1 and other variable to variable 2. I am moving pre-test to variable 1 and then post-test to variable 2. Then click OK. This is output of SPSS. First box is paired sample statistics. It is descriptive statistics or descriptive information about the variables. This will be helpful while reporting descriptive information in your dissertation. You can see it gives mean of both the variables, then number of participants in both the test, pre-test and post-test, standard deviation and standard error mean. Second box is correlation coefficient between two variables. We do not need this information to know the significance, but we need this to calculate effect size to report in the dissertation. It simply means if coefficient of correlation is high, which is good for the paired sample t-test. Larger the coefficient of correlation, less will be the standard error. In our case, coefficient of correlation is 0.906. So it is very high. That means it is good for paired sample t-test. Third box is paired sample test box, which is inferential statistics to know whether means are statistically significantly different or whether we can reject null hypothesis or not. We need this table. As we have done in one sample t-test tutorial, we have three ways to determine this. First way is to check the t-value if t-value is greater than the critical value on t-table at degree of freedom 24. In that case, we can say these means are statistically significantly different. Now I need to check this critical value. I need to compare critical value. So let's go to the t-table. This is t-table where this is critical value at degree of freedom 24. This is 2.064. So let's compare it with t-value. Our t-value is 5.313. In this case, t-value 5.313 is greater than critical value, which was 2.064. So I can say t-value is greater than critical value. That means are significantly different, statistically significantly different. Here negative sign shows that second mean, which is post-test mean, is higher than first mean, pre-test mean. If we will reverse the order of variables while entering in the dialog box, we will get the positive t-value. That means it does not bother whether sign is negative or positive. In t-value, t-value would remain same. That's why we just use positive t-value here. Next, second way is to check the significance value, which is 0.000. If our p-value is less than 0.05, then we can say means are statistically significantly different. Our case, p-value is 0.000, which is less than 0.05. That means are statistically significantly different. We can report it in our dissertation like t degree of freedom, which is 24, is equal to our t-value, which is 5.313 at p-value 0.000. So this way we can report this in our dissertation. Next, third way is to check from the confidence interval. If it does not cross 0, means are statistically significantly different. As in our case, both lower bound and upper bound are negative. That means it does not cross 0. So from all the three ways, we concluded means are statistically significantly different. Hence, reject the null hypothesis. Also, mean of post-test, which is 83.76, is greater than mean of pre-test, which is 79.72. That means cooperative learning increases marks of students. There's increase in marks of students when taught through cooperative learning. That's all. Thank you. If you like my work, please give thumbs up and subscribe to Dr. Sumit Bakshi.